So if you will remember what we were working on last Friday, sorry, we were solving rational equations and inequalities. What we did is we were able to solve all of these questions by looking at the graph. Now remember, greater than, what does greater than mean graphically? Above the x-axis. Less than graphically means below the x-axis. Equal to graphically means good on the x-axis. But then we said, well, what if all we have is the rational expression? What if all we have is this and we don't have the graph? How can we solve those questions just with the rational expression itself? So now this is the last one that you're actually going to be given all the steps, but hopefully you don't need the steps anymore, but it'll come in handy this time just because you haven't done this since last Friday. Okay, we are solving this rational expression less than 0. Graphically, what would I be looking for? Below the x-axis. Okay, so steps. Remember, step 1, factor completely. It is already factored completely. Hallelujah. Number 2, every factor that you see, you're going to set equal to 0. That allows us to find our critical numbers. Critical numbers are where your fraction is either equal to 0 or undefined. Now, how can a fraction equal 0? Good. 0's in the numerator. How can a fraction, earbuds out. If you have wireless earbuds, earbuds out. How can a fraction be undefined? Good. 0 in the denominator. So, what x values would we consider to be critical?
-3, -2, and 1.
Perfect. Now, bless you, now we're going to put those on a number line. And I trust that you know what order to put them in.
I don't know. I can't square numbers.
How many subintervals or sections has the number line been divided into? 4, right. So we're going to pick a number in each of those subintervals or sections. Pick a number less than -3, between -2 and -3, -1 would work. What's the matter? Good? Okay. Now, we're in step 3. We chose a number from each interval, but now we're going to determine the sign of each factor based on the number we chose. So what we're going to do is we're going to take this -4 right here. We're going to plug it in here and here and here, and we're going to say, does -4 make each of those factors positive or negative? If x is -4, positive or negative?
Negative.
So that's a negative times a negative divided by a, and a negative squared is a positive. In fact, in every one of these, what is your denominator going to be? Why is it going to be positive? Because you're squaring it. Good. So what does this give me? A negative times a negative divided by a positive. So here's what we know. Every number smaller than 3 is going to make this bad boy negative. What does that tell us about the graph? Every number less than -3 is going to make this be where? Well, sorry, did I say negative? I said negative. Rerun. This is positive. Every x value less than -3 is going to make this thing positive, which means where's it going to be on the on the graph? Above the x-axis. Yeah, tell me when I screw up. Do you ever go, you say something and then you go, what did I just say? Yeah, okay. All the time. Okay, well, all right. -2.5. Positive. Right, because a positive times a negative is a negative, and a negative divided by a positive is a negative. Every number between -3 and -2 is going to make this expression negative, which means where is it going to be on the graph? Below the x-axis. Okay, get my words right this time. Use your words. 0. Positive times a negative divided by a positive. What's that? That's a negative as well. X equal 2. Positive times positive divided by gives me a. Now, let's look back at the question. The question was, when is that fraction less than 0? Oh, there's one other thing we needed to do. Look at these critical numbers, -3, -2, and 1. Which of those, if any, makes the fraction undefined? -2 will not be an answer to anything because -2 is not even in the domain of this function because it makes it undefined. There's a vertical asymptote there. Now, x equal -3 might be an answer because when x is -3, what is this thing? 0. When x is 1, what is that thing? So those are included if it's less than or equal to or greater than or equal to. Is it? No, just a less than on this one. So where is your answer? Well, your answer is everywhere that I have a what circle? A negative. So your answer is everything between -3 and -2 and between -2 and 1. You with me? Now let's talk about that graphically. This is the graph of that thing we just worked through. Let's look on your graph for this section. We're looking for the graph between x equal -3 and -2. That's all below the x-axis. Between -2 and 1. That's all below the x-axis. Bless you. We just validated our answer. We just confirmed our answer because all of the answer that we gave here, the graph is below the x-axis. Now here's what I would like for you to do. Oh, no, we got to do this one together. Never mind. Do you have your calculator? Here we go. Solve each of the following rational inequalities. Show your complete sign analysis. When is this sign analysis? Yeah, sign analysis means this here. This is your sign analysis. And check your solution using a graphing calculator. How could you check your answer to this using a graphing calculator? So what are you looking at on your graph compared to your answer? In this case, what are we going to be looking for? When it's above the x-axis or on it. Right. Above the x-axis or on it. All right. The first thing you do is find your critical numbers by factoring. Okay? Go. Won't factor. Well, snap. Won't factor. Now, I can tell one of my critical numbers, right? One of my critical numbers is 3. But what makes my denominator 0? Well, snap, I don't know. So I got to go over here and I got to think about this. I got to solve that little equation right there. Now, you have 2 options because it won't factor. What are your options? Complete the square or quadratic formula. Now, what we're going to do is we're going to complete the square because I don't want you to forget how to complete the square. Yeah, I know. That's why we're going to do it. That's why we're going to do it. Now, listen. This one's real easy to complete the square. If your leading coefficient is 1 and the coefficient with the x is even, completing the square is easy. So let's just, if that number was odd, I'd be saying let's go to quadratic formula because I ain't completing the square. Let's just remember how to complete a square. We're going to move the constant to the other side. Then I got to decide what number goes right there. Not 16. What do you do with this 4 right here? Half it and square it. Good. Half of it is 4. Square it is 4. But if I add 4 to one side, I add 4 to the other side. Got to keep my teeter-totter balanced. I do too. X squared plus 4x plus 4. If I have put the right number in there, this will factor into something times itself. How will x squared plus 4x plus 4 factor? Perfect. X plus 2 quantity squared. If you just say x plus 2 squared, what's being squared? Just the 2. Yeah. Solve it. How do you solve it? Square root. So I get x plus 2 equals square root plus or minus square root 2. How many answers did I come up with? 2 of them. They're my other critical numbers. So my critical numbers are negative 2 plus root 2 and negative 2 minus root 2. You okay there? Now here's the deal. I don't know where to put those on my number line because I don't know what they are. Go to your calculator, blank screen, and get an approximation to 3 decimal places for both of those. Which one did you get, Gisela? Negative 3.414. Gus, did you get this one? What is it? 0.585? 585, 586, okay. Okay. Go to your number line. Now here's what I'm going to do. You're going to finish it. I'm going to finish it. And I'm just going to talk kind of quietly into the microphone for Alyssa and Jael. I'm not going to talk to you guys, but I'm going to write it up here. And If you get stuck, look up here and see if you can figure out where you got stuck. Okay, ladies. Let's see, that's going to be, oops. There's the negative 3.414. There's negative 0.586. And there is 3. So let's pick some numbers. Let's pick negative 4. Let's pick negative 1. Let's pick 0. And let's pick 4. Okay, if x is negative 4, the numerator is negative. Now, if x is negative 4, I've got to crank on this. Negative 4 squared is 16, plus 4 times negative 4 is negative 16, plus 2, that is positive. And a negative divided by a positive is a negative. If x is negative 1, negative 1 minus 3, that's negative. And if x is negative 1, negative 1 squared is 1. 4 times negative 1 is negative 4, plus 2, that's negative 1, I think, so it's negative. A negative divided by a negative is a positive. If x is 0, 0 minus 3 is negative. And if x is 0, that's 2, so that's positive. Negative divided by a positive is a negative. If x is 4, 4 minus 3 is positive. And if x is 4, the denominator is positive as well. And a positive divided by a positive is a positive. Whoops, sorry about that. That's supposed to be a 3. Now, let's see what I'm looking for here. I'm looking for greater than or equal to 0. This number and this number make my fraction undefined. Sorry. Now, this number makes my fraction equal to 0. And since I've got an equal to 0, I will be including that 3. Now, the greater than means I'm looking for the positives. So positive is here. So that would be negative 3.414, which I think was negative 2 minus root 2, comma, all the way to negative 2 plus root 2. Neither one of those are included. And here, 3 to infinity, but the 3 is included. Class is going to do this one. I have a student I need to talk to for a second, and I'll come back and do this one with my mute button on my mouth. Okay, bye. Okay, everybody's finished, looks like. So let's talk about answers here. We're looking for less than. So are you going to have any brackets in your answer? No. Graphically, what are you looking for? Below the x-axis. What'd you get? Negative infinity? To where? To where? Is that right? Yes? Yeah? Okay, good. Now we have one more. Did you get it, Dylan? Yeah. All right, we have one more to look at. How does this one look different than every problem you have done so far? There's not a 0 on one side. We got to make it happen. How do we make that be 0 on one side? So let's write 3 over x plus 2 minus 2 over x minus 1 is less than or equal to 0. Now we're going back to algebra 2. That has to be a single expression on the left side, not two fractions, one. Ah, common denominator. What is your common denominator? X plus 2 times x minus 1. Good. This one needs, why can I do what I just did? Because I'm multiplying by 1. Good. Because x minus 1 over x minus 1 is 1. X plus 2 over x plus 2 is 1. And I can multiply anything by 1 and I still get the same answer. I tell my Algebra 2 students, because we're working on this stuff, not with equal signs, not with a less than. If they will just do this, it'll make life a lot easier. If you just rewrite that as plus and negative, that way you don't lose that minus sign. If you want to do that, that's fine. I trust you that you will take care of what you need to do. All right, common denominator is x minus 1 times x plus 2. What's my first numerator now? 3x minus 3. So what have we got? X minus 7? Now we finally got it down to a point that we can follow our procedure. What's the first thing we're going to do? And find your, what are we finding? What do we call them? Critical numbers. What are our critical numbers? 7, 1, and negative 2. Can you finish the problem? Do we have a need to finish it now? Okay. All right, we're done.